And you guys probably need to see what's going on here too. And I need this real bad. I met some people I'd never met before, and so we met with masks on, and we sat down, and I pulled the mask on, and they're all off their beard reveal. Oh, hey, see, it's like it doesn't even matter anymore, right? It's like, what do you? Yeah. Oh. You guys have a game this weekend? Next week? Okay, that's not too bad. Oh, really? You guys gonna play on the main field? On the turf? I could probably sneak in there and watch it, huh? I mean, I'm a coach. That just happened to be. No, I just got hired. Maybe I shouldn't have. All right. Do you know how to push a button? I don't even understand, Coach. Like when they add minutes at the end of the game, I don't understand all of that. Honestly, I understand a lot of the soccer rules, but it seems so arbitrary. Like, where does this time? Trying to limit the international players falling down. Yeah. Okay, that's it. All right. Well, oh my gosh, it's taking me so long to get all of my classes started today. It's Monday. So, lesson 4.4, we're going to learn about conditional probability and independence. How to determine if two events are independent using this conditional probability rule. And there's like a video on this one that's like not terrible. I was thinking about maybe playing it. That was the thing I was going to try. Man, everyone and their mom wants to get a hold of me right now. Sorry. Okay. So I already said we were going to do this stuff. Awesome. So we've got conditional probability. So we're talking about the probability of one event occurring given that another event has already occurred is essentially what we're saying. And the way that we write that is probability of B. And this little line here, I say this as given. So I would write this as, probability. Ooh. Let me write this as. Right, and so I guess I really wanted to say. So essentially, this little line, you could represent that with the word given. P, probability of B given A. Did you get any of these, Coach? See these? They're from Mr. Danielson. Really? Yeah, go for it. Hit them up. All right. Okay, so if we look at it on a two-way table, we'll be able to see that this happens. And we'll look at a two-way table here in a minute. But these are just pretty much some formulas that we need for this particular probability. So the probability of B given A is the probability of A and B divided by the probability of B. And that's it. This is the formula pretty much we're going to be using for this lesson. All right. So, if you're going to toss a fair coin twice, we would say event A is the first toss is a head, event B, second toss is a head. We know that the probability of A is equal to 1 out of 2, and the probability of B is 1 out of 2. And what we're going to do is essentially show you how we can determine if two events are independent using this conditional probability rule. All right, so what is the probability of B given A? In other words, what is the probability that you roll a, what was that? They're both heads, right? Okay. That you roll it. I've got a die that's heads and tails. No, I don't. The probability that you toss a coin and it comes up heads the second time, given that you got heads the first time, right? So this is essentially saying this is the probability that you get heads on the second try, given that you got it already, right? So, I mean, that's what it says. Sorry, I don't need to write that down. So we're showing that the two events are independent, right? So what we're trying to get at is that it doesn't matter, right? If the first coin comes up heads or tails, right? It doesn't affect the probability of the second one coming up heads or tails, right? And what that is saying that those two events are independent, right? If the probability of one event occurring doesn't affect the probability of another event occurring, then the two events are considered to be independent. And we can determine whether they're independent by seeing if the two probabilities fulfill this rule. And we'll be doing that. So, and there it is. You are going to have to check this, okay? So if either of these things are true, right? Either this or this are true. If any of these things are equal, and that's really what we're going to be checking. This is predominantly what you'll be checking for. That one. All right. Good times. So I was really thinking about doing this video thing. So when we're looking at given, right? If we were saying, hey, what's the probability of a person being in liberal or large school given they got an A, right? We would only, right, so given A, we're going to be only looking at this row if we're being asked something like that. So let's go through this example as well. I just wanted you guys to get a couple examples. I thought that one wasn't really going to do the trick. So let's read this thing. Students at the University of New Hampshire, I almost said New Mexico, that's kind of weird, received 10,000 course grades in a recent semester. The two-way table breaks down these grades by which school of the university taught the course. The schools are liberal arts, engineering and physical sciences, EPS, and health and human services. Choose a University of New Hampshire course grade at random. Consider the two events. E, the grade comes from an EPS course, and L, the grade is lower than a B. Let's look at the probability of P given, probability of L given E. So the probability that the grade is lower than a B, given that it comes from an EPS course. All right. And I think I might put this actually in a different page. Give us a little more room. Let's go. freaking Tony Stark, but just kidding. No? Okay. All right. And then I want the questions. Wow, that's quite large. All right, probability of L given E. And we'll remember that L is lower than a B. And E comes from an EPS course, or environmental science, right? All right. So the probability that it's lower than a B, given that it comes from an EPS course. All right. So then we're looking at these guys, right? So this is our total. So we're just looking at that column for this one. Okay, and let's get out our formula as well, right? Let's get out the formula. Sorry, let me make sure I. Okay. A and B over B. So, okay. So that 800, right? That's the probability. Those are the people that both have a grade lower than a B and are from the School of Engineering and Physical Sciences, right? So that's the 800 we're looking at, right? Yes. And you would wind up getting, 800 for that, I think. Right. And then the probability that it is an engineering. So all the things that are engineering are all these guys, right? Everything in the column. Yeah. All right, and we can calculate this. Oops, I won't do that yet. So 1600 or we'll wind up with, huh? Yeah, it's 1/2 exactly. I was like, do I want to write 0.5 right away, or do I want to just? I'm gonna write the 1/2 first, which is 0.5, right? 50% of them had a grade lower than a B. All right, and let's interpret this probability in context, right? So they're asking for some words in this answer. Yeah, let's start with the 50% of students. I guess you could say if a student is chosen at random. Better way to say that. Sorry about that. So we say the probability that the let's see, what do I want to put first? Has a lower grade. No. All right. And I'll scroll that up for those of you that are here. All right. So that one was not quite as gnarly. The next question has a little more to it. But we'll get there in just a second. All right, cool. So next, are events L and E independent? Okay, are events L and E independent? So let's go back and we have a formula. So we're going to be checking that this is true. Okay. I guess either way. Yeah. Probability A given B. I think either one will work. Trying to just really pick out the case that is the easiest, right? We essentially have 4 different cases, right? I could check just separately that that's true, right? I could check separately that that's true, and that's what I'm leaning towards. Or I would check that just this is true. And I'll show you how that's going to work. Let's see. I think we're going to do this: A given B complement. Yeah, that's what I chose. All right, let's write down the question and let's get this thing going. I do actually want to write this down right because this is not a formula that I have. All right, let's see if we can prove that this is true or not. And we're going to need all this stuff. All right. So we have already shown that we already know that the probability of, we said it was L given E, right, is 0.5. Okay, so we would like to know so we want to check, is the probability of L given E equal to the probability of L given E complement, right? We would also like that to be equal to the probability of L, the probability they have a low grade. All right, let's see what's up. So if these things are independent, then it's got to be the case that that they're the same, right? That these things are all the same. When I calculate all these things, we should get 0.5, right? If they are indeed independent. All right. Okay, so we know that this is 0.5. Let's see, what is the probability of L given E complement, right? So what's the probability that they got a low grade given that they're not in the School of Engineering and Physical Sciences, okay? All right, so, all right, so if we're looking at, all right, grades lower than a B. All right, lower than a B. Sorry, guys. Lower than a B is all these guys, right? Oh yeah, and let's see the, right, that's lower than a B. If we use our formula, all right. Correct, sorry, let me just double check my formulas. Hate writing stuff down when it's wrong. L and E probability, E good. L and E complement probability, L. Whoops. I think I did write something down wrong. Sorry, cool. I'm glad that I checked. Because this should be E complement. Sorry. I had a feeling something was off. There we go. That's better. All right, and we can get all of this stuff from our two-way table, right? What things there are low grades and not in the School of Engineering, okay? Well, that is going to be this one and this one, right? Those are, or wait, lower than a B. No, we want lower than a B, my bad, not a B. Lower than a B. So that's this one and this one. Sorry about that. Cool. All right, so 68 plus 588. All divided by, now we need all of the things that are not school and engineering sciences. So well, that's all of these things. So there are, okay. Like, do I trying to decide if I should just do the whole column, right? It's all of that, right? All of that is E complement, right? Not in the School of Engineering. So we got to add up all of those things. So, right, because it's either this or that or that, right? And that's why we're using addition, right? Each one counts. Each one counts as a success. So 2142 plus 1890 plus 2268 plus 82. Oh my goodness, I'm not running out of room. No, I'm not. I've got this. Plus 588. Okay. We can calculate that. And now I'm just adding these up. Added up the numerator. Now I am adding the denominator and making sure I'm not making any mistakes because I'm talking and typing numbers at the same time. Good job. All right. 8,400 in your denominator there. We'll go ahead and calculate this bad boy. And I get 0.34, which is not the same, right? So the probability of L given E complement is equal to 0.34. Therefore, the probability of L given E does not equal the probability of L given E complement. So we would say they are not independent. All right. And I mean, also not the probability of L, right? What is the probability of L? Just to, I mean, it's another way that we could look at it, right? We have the question answer, but I'm also curious, what is the probability of a low grade, a grade lower than a B? Oh my gosh, how many students were there? So that's 2268 plus 800 plus 588 divided by the total. Does it say how many students they looked at in the beginning of the problem? 10,000. And we could show that these two are also different. So that's 3. Oh, duh. That's so stupid. I don't know why I put that in my calculator. Right? All you got to do is move some decimals over. Right? 0.3656. And that also is not equal to the probability of L given E, right? So we've shown it in many, many different ways that those two are not independent. And you can choose either of them. I just chose to show you every single case, right? You could do this and say that because, right, you could do the probability of L, because the probability of L is not equal to the probability of L given E. If that's true, then you could say that the two things are not independent. And then likewise with finding the probability of L given E complement. I just chose to do the more challenging one first because I think you get more out of seeing a really hard problem and then doing one that's a little easier than the other way around, right? So there it is, guys. Your assignment is exactly this question with different situations. That's it. All right. And there you go. We did it.